All right, we are live. Thanks for tuning into the Sheet Metal Shaping podcast, where we discuss the pursuit of sheet metal shaping education through traditional coach building techniques. My guest today on the show, all the way from New Jersey, the one and only Mr. Rob Ida. What's up, man?
Hey, how you doing, buddy?
I'm so excited for this. Coming all the way from USA. Pumped. Very cool. What's going on with you guys?
Just stayed busy. We're short-handed and overcommitted, but I guess that's pretty common in this industry these days.
So I want to talk about the Figur technology that you've been promoting and talking about on Instagram lately. For anybody who doesn't follow Rob on Instagram, make sure you go there, Rob_Ida. He's got a really well curated Instagram, and your website is like gorgeous. I was cruising through your website over the last couple of weeks, and it's just like, your photos are amazing. You've been everywhere. Your cars have been SEMA, Amelia Island, the Playboy, like all the places, man.
We've been around. We've been at this for a long time.
Super cool. Super cool. So so we'll kick it off. We'll talk about the 3D shaping technology, go from there. And then I want to hear about what you're working on as well. You guys, as you say, you're busy. So tell the folks a bit about yourself.
Okay. So I'm the third generation in this business. My grandfather originally started in New York. He had a Tucker dealership in Yonkers, New York in 1947, 48. And that kind of started the family business, or started the family in the automotive business. And then from there, my father and him had in New York City, they had a repair shop, and they had the ability to build some race cars. And so I always kind of grew up around cars, and I grew up around race cars and hot rods. And then when I graduated high school in 1990, my father and I decided that we would start a hot rod shop together. And so that's what we did. And we started the hot rod shop back then in 90. And we always kind of had a mix between modern technology, vintage styling. We like traditional hot rods, but we're also interested in in new technology as well. I mean, we were doing fuel injection stuff back in the late 80s. And we've always stuck with that. So we kind of got our hands on all kinds of stuff, race cars and hot rods and restorations.
Nice.
We've done a few restorations of original Tuckers. We've made some of our own Tuckers, and just lots of different hot rods and customs and things like that.
Do you have a preference? What do you like working on the most? If you could only do one car for the rest of your days, what would it be?
Well, see, I'm not cut out for that. I am not into redundancy. And there was a time early on when we were actually creating fiberglass bodies for Willys cars and reproduction, hot rod or street rod style chassis. Back in the 90s, that was kind of, the thing to do. And I just hated it. I hated it because it was like factory work.
Right.
And so I'm really not cut out for that kind of stuff. I like being creative, and I like making new things and trying new stuff. So I've decided that less production, or at least minimal production, small run things are okay for me. But not I'm not the type to do the same thing over and over and over again for years.
On to the next. That's the creative side. I find like there's a lot of people who out there who are like entrepreneurs, and they say, I only want to do one thing because I can do a billion of them, and like boom, that's it. And then you get the artists who say, hey, this car has to have a soul. This car has to have, a certain flavor. And like, I want to build this, and then I want to do something completely different. It sounds like that's your style.
That is. And that's a really good point, because I'm always kind of like dealing with that struggle. Do I want to be the creative artist, or do I want to be a good businessman? And sometimes you have to find that balance between those two things to make sense. I mean, at the end of the day, we still have to pay our bills, and the employees need to get paid, and everybody needs to, get what they have coming to them. So you can't be in fantasy land all the time.
That's right.
You have to find that balance. And I've struggled with that over the years, trying to find balance. And so I just turned 51. And when I turned 49, so 2 years ago, I decided I'm really going to like find balance, and I'm going to take care of my health. I'm going to prioritize sleep and eating right and all the things that I used to throw away just for work. Like I didn't care if I didn't sleep for days. I wanted to, just finish this car. And I decided that, well, I can either die young, or I can do this for a lot of years if I just change a couple of things in my life and make some better decisions and be a little kinder to myself. So I've been doing that over the last couple of years, and I found that good just good daily habits add up. They do. for sure.
You know what? Net, if you get better sleep, you can do more cars long term. That's
Exactly.
how you're going to justify it, right?
I used to sacrifice sleep like that for any reason. I don't know, bro. I don't need to sleep. I'll work all night. And that stuff does catch up to you. I mean, I did it for years. I did it for 30 years. That's how I treated myself.
Yeah.
And so now I decided that I'm gonna find a little bit more balance and be a bit kinder. So that's what I've been doing over the last 2 years, and it's working. And I can't imagine going the other way.
Yeah.
Now that I feel that.
So from the business side, is that how the 3D forming and shaping technology came to be, or was that your artist, or was that both?
Both. All right. So first and foremost, I'm a car builder. So I do metal shaping, right? So I do that too, but I also build chassis. I paint cars. I design. I cut glass, like whatever it takes to build a car.
Yeah,
I do. So I'm always trying to find the best way to get it done. When we first started, we had a Bridgeport, and we used to, crank the Bridgeport around and make a part, and it would look like a block, but it worked. And after a while, we realized, we could get a CNC machine and do 3D stuff and make it a lot more efficient, and not only make it better, but do it in a timely fashion. It's nice to have endless amount of time to do something, but that just doesn't happen in the real world, So you have to find ways and tools and ability to make things better, faster, more efficient. When the quality goes up and the hours wasted, and I'm talking about spending time is important. That's never going to go away. You're not going to ever do anything with a snap of your fingers. No matter what, you have to spend the time to get it done right. But if you can find ways to get it done right in a more efficient manner, I'm interested in that. I've always been.
Yeah. Does that make you more competitive in the market, you figure?
Well, I'm not really a competitive guy. We're a small group here. We've always been maxed out, as I think most shops are. I can't think of a shop that is looking for work. I mean, this industry has always been very busy throughout all different economies. At least for us, that's how I've recognized it. There's never been a slow season.
Yeah.
So I don't really worry about being competitive. You do worry about how many hours get thrown away. And, most metal shapers or car builders that I talk to, it's always the same story. I can't find help. I lost money on that job, but I just wanted to get it done that way. And, I could never get paid for all my hours. Like, this is the same story that we all say. I mean, it's just part of it, right? It is, because we want the car to come out better. So that means taking a couple of steps back, redoing something. A new idea came in. Now you want to incorporate that. So there's always a lot of hours that are given away. And I shouldn't say wasted. They're invested somehow in your product, right? I mean, it's an effort to build a better car. But it's good if you can find ways to shorten that up, and if you can still get these things done without having to give away all the hours. I mean, I've done it where we're here at the shop for days and days and days straight without any sleep or any rest. And sometimes you have to do that, but we want to keep that to a minimum. That was definitely becoming a habit. I was like building that in, like, okay, this is the pace that it is. And so now I realize it's more important to work at a manageable pace, especially if you want to have, a team that wants to stay with you. And I've had, employees for, lots of years. So I think it's important to not give away time.
The crew's probably like, hey, we can only do granola bars and mac and cheese on the shop floor for so long before we need a pillow and a blanket. Rob, come on.
Well, there was definitely times in my career where I expected way more from people than I probably should have.
Sure.
But they've stuck it out with me, and it's been good. We've done a lot of good things over the years.
So let's talk about this tech itself. Like, can you describe what it is for the person who's never heard of 3D shaping technology?
Yeah, so it's incremental metal forming, and it's a CNC machine that is not cutting anything, it's pushing. So imagine 2,000 pounds of pressure, concentrated, almost a fingertip sized tool, pushing down on metal, and that metal is backed by a silicone pad, and that silicone pad is on a bed that moves. So you're keeping pressure against the silicone pad with the metal in between. And it starts from the outside in, and it pushes down the metal. It's stretch only. There's no shrinking and there's no bending involved. It's completely stretch. So as we know, you can't do everything with this machine. It's not the end all in metal shaping. And I realized when I first kind of made a posting about this, I struck a nerve with some people, and I realized, oh, wait a minute, no, this is not going to replace the talented metal shaper. And this is not going to replace the power hammer or the Englishwheel or the Echo or pullmax. None of that. It's another resource that you can use. It's another tool that you can use to make your life easier and better. Choose when to use it. So it's not going to replace all those things. In fact, my philosophy here is that more shops now will have access to shaped pieces, right?
Right.
Just like when 3D printing started to become available to shops like ours. You don't necessarily have to own a 3D printer. You can use a source. You can have an idea, whether you do the CAD work yourself or someone does it for you, and you can get things printed. A lot of shops do have them in house. We have Reversion Raceworks here, which is a division that we have for just 3D printing, and it's been a very useful resource, not just us, but to other shops as well. Sure. So now that a shop who maybe didn't have any metal shaping experience or equipment or anyone on staff that could even do it, they may say, oh, here, I have an idea that I would like to incorporate in this car. Can I have, a third party CNC form this piece? And the answer would be yes. So if they can do that, well, now they need somebody that can finish that piece, because it's not going to come in the box and you're going to bolt it on the car. It's not going to make it a whole car. It's going to be something to work with. Imagine if you were to buy a rusted out section of a trunk pan for a kind of an obscure car. A car that you're not gonna stamp out 100,000 of them. So it doesn't pay to make stamping tools. It doesn't pay to make 100 of them by hand, and you're going to put all the ribs and the shapes, and it doesn't pay to do that either. So really, what do? You kind of get through it. So one shop at a time will fix that rusted out inner pan section one way or another, whether it looks good or it doesn't look good, or they just kind of put in some flat metal. Either way, it's going to be repaired somehow, some way. And if somebody is going to spend the time to do all the shaping to make it look like a stamped piece, like it would have been, it's going to be an expensive little corner of a trunk or of a trunk pan.
Yeah.
But imagine if you can maybe scan that car, and if you took a digital scanning of that section, and it was a kind of a deep drawn, rounded, what was a stamping with ribs in there. Now you can make that piece, okay? And you could say, okay, now I have that file, and having the file is like having a stamping tool.
A die, yeah.
But you don't have to have the die. You don't have to have a stamp. You don't have to have the die. You don't have to invest the money in that die. And as we know, when these dies start to deteriorate over time, they lose their tolerances. Yeah. So how many times do we hear people say, oh, I bought a roof for 55 Chevy and it doesn't fit at all? Well, it probably fit the first time, or at least it was better the first time they stamped one. Yeah. By the time they get to 1,000, the thing doesn't fit anymore because it lost all of its shape and it doesn't fit anymore. Well, if this trunk pan for this Pantera was now in your file, which it could happen in hours, right? Yep. With scanning, a digital scanning. Now that thing's in your system. And you sell 1 or 5 or whatever you do. And then 3 years later, somebody calls up and orders one. Well, there you go. There's the file. I have the piece. I didn't have to store it. I didn't have to, have 100 of them ordered so that I could keep them on the shelf because that's the minimum. I can just make one. And then there you go. Now that exists. And that type of thinking, I think, is really where this technology is going to really serve the industry best.
For sure.
Now, the posting I made was on my Tucker karaoke project, which normally is a handmade car. And I think that was a little upsetting to people because they want to see that made on a power hammer and an English wheel and however else. And that's most likely how I'm going to still make that car.
Right.
But we were testing the equipment, trying to push it to its limit. And we saw that nose cone as this is a deep draw, right? It's like 10 inches. The thing will do 16 inches of depth. Wow. So we said, like, really, let's push it to the limit and see what this is. We're talking about a 60-degree taper.
Yeah.
It's like a bucket with a headlight in the center. So we got this kind of a squared off corner all the way at the bottom. It's a reverse curve, a few different reverse curves. So it's a pretty complicated shape. And we said, this is a good way to like put the thing to the test. You know, what can it do here? Would I make that for a one-off using that machine? Maybe if I own the machine, I might. Would somebody order it? Maybe not. I don't know. That depends on the shop and the part. You know, if it's not all these compound curves and all that stuff, you probably would just make it by hand anyway, you know, on your power hammer. But it was made in one piece, and it fits the buck. We measured the thicknesses. I don't know if you saw the second posting I made on it.
I did, yeah. You cut it open and mic'd it.
Yeah, I cut it open and mic'd it.
Yeah.
And so what it does is there's kind of a loose formula, and we're still playing with it because, as I said, it's very, very new to us. It seems like a 60-degree angle on the sides results in about a 40% loss in thickness due to the stretching. And I think as time goes by, that type of information is more predictable. It's pretty predictable now on the CAD. It'll become better and better as we get more experience with this thing. So you can be strategic in the parts that you make and how you make them, right? So we made that thing in one piece, and that was really like wild. And and the reason why I chose that piece, I'm like, oh, here, I have the file for that. Let's make this, see how it does. And it made that part in 32 minutes. And right, it's amazing in one piece.
Yeah.
But the reality is somebody still has to cut it out and then fit it to the next part, weld it, finish the weld, you know, all those things still have to get done. So there will be a need for more metal shapers, I believe, in the industry as this technology starts putting more pieces in different shops that maybe weren't doing any metal shaping before. Yeah, so I'm not worried about it replacing the metal shaper. In fact, I think it's going to increase the need for more metal shapers. It would have to. So the unit can do a sheet 63 inches by 47 inches.
Wow, that's big.
It is. It's pretty big. Yeah, I mean, you're not gonna make a roof, you know, in one piece or anything. And you probably wouldn't make a roof anyway with it, but you could make sections of it. And I'm thinking, imagine like the quarter window, right? We're chopping a 34.5 window at the moment, and there's a lot of detail in there, right? There's a lot of detail around the window opening and the way the character lines taper. You know, they're not just one constant profile. They transition out of there. That's a great idea for this type of thing. Not only are they the same from left to right, because whatever that file is, you just mirror image it. And you could have it on both sides. You could save you a lot of time and make it more accurate and a better piece, you know, rather than chopping the old pieces and sectioning them in and, you know, making 1,000 little guys to make one piece. You can make it in probably one piece. So I think that's where it's going to really shine. Imagine making valve covers or an oil pan for some obscure restoration. And you want to have the script in there where it looks like it was, you know, a stamped out piece, you know, engine tins for old restorations and valve covers, brightwork and trim. It'll do stainless steel.
Nice.
Yeah. So right now we're working on making the trim for the Carioca just to test it out, see how it is. I mean, normally I'd make that stuff by hand, and I still make some of it by hand. But if it could save me some time and it could make a nicely fitted part, I'll take that advantage for sure.
Yeah, man. Some of those obscure headlight bezels for various cars that you just can't find anymore. I mean,
Right.
that'd be beautiful.
Right. Yeah. And how many cars, we like to say we'd love to restore, but it just isn't worth doing, right? Because if
Right.
the car isn't valuable enough, and as shop time gets more and more expensive, I mean, here in New Jersey, my local Toyota dealership is $185 per hour,
Yeah.
right?
Oh my gosh.
That's to work on a Toyota. A Toyota that will get fixed with things that have part numbers, and that have a repair procedure.
Mm-hmm.
We don't have those luxuries, right?
There's no Haynes manual for all the
right.
cars you build. Come on.
Yeah, there's none of that. So it's all labor, and as labor gets more and more expensive, because no matter what, we have to employ someone that lives in the same area that the Toyota dealership gets $185 an hour for.
That's right.
So you have to be competitive with these things, and time is very, very expensive. So as right now I'm restoring a Tucker. It happens to be the Tucker that Preston Tucker himself owned, right? Mm-hmm. They require a tremendous amount of metalwork.
Yeah.
They are built using like 300 pounds of lead from the factory, and because the parts just didn't fit. Right. They were poor stampings made of thin material, assembled by guys that were in a major rush. So they would smash the panels down with a pig hammer and then
lead over
them just so that the seams fit. So the profiles don't match,
mm-hmm.
but the seams come together. So the door has a completely different contour than the fender does, but they meet in the middle. That's the only thing they were worried about, was that they met in the middle, and however they get there, they get there. But the standards now are much different, right? So we have to make these cars look better than they ever did, and we can't melt out an inch of lead and then just mud it up. Like, you can't do that. So we're replacing sections all the time on these Tuckers that are, it's also a judgment call, because if I was to replace every inch of questionable metal on the Tucker, I would rebody the entire car.
Right.
That's not the goal. We want to maintain as much of the car as we possibly can, and only replace what we absolutely cannot salvage. And sometimes that's 3 inches of a fender all the way up the middle, and it's a pretty difficult task to make good metal of those cars.
For sure. It's funny. I had somebody on the podcast earlier on, Aiden from Bespoke Coachworks in Australia, and we were talking a bit about, you talked about labor, and him and I were talking about labor and the actual cost of labor versus material that goes into rebodying a car. Like your $2, $3, $4, $5 in material itself, like the aluminum or the steel, which is peanuts compared to how many human hours it takes to get this thing to where it's got to be. You know what I mean? So I totally understand with what you're saying. Like, how much can you salvage versus how much do you just rebody?
Yeah. Well, those cars have at least, enough dollar value to justify a lot of this work. But what about cars that we still want to save because we love them, but they're not worth millions of dollars? So we can't spend $500,000 restoring a car that's worth 80, like that just doesn't make sense.
So where does that go? Does that go into the hobbyist vein as opposed to the business owner vein for the restoration enthusiast, or?
Well, I see a lot of cars, and I tell customers that come to me, and if they want to build a car that I know they can buy it already done at Barrett Jackson for half of what it actually costs to build, do it, because you can have it right away. You don't have to wait, and it's going to cost you a lot less money than it is to go through the whole build process. And I think most people would agree that that's true. I mean, the math just works that way. So we do have to find ways to make things, more cost effective, because budget matters, And if we want to, like, I love making a beautiful fender, right? I love to do that on whether it's Englishwheel or powerhammer or both. I love doing that, right? It's very rewarding, and it's just so satisfying watching it come together. But what I don't love is making like inner rocker panels, right?
Yeah, right.
Like that I don't love. So if I can use the Figur machine to do that, build all my door jambs and those pieces are exactly mirror image left to right, and they're done in a reasonable amount of time, and are all figured out on CAD. So when they go together, they make sense. And then if I want to shape my pieces to fit over those parts, I mean, that's the perfect combination for me.
Absolutely.
You know, I think that's great. I've made
nobody ever said, Rob, hey, nice rocker panel in that car. Ooh, that
exactly. Right.
Nobody says this.
Right. And that's why I know that, you know, a lot of this stuff is emotional more than anything when the metal shaper thinks that he's going to be replaced by the figure machine. And it's not going to happen. It's just, it's not, it'll never happen. And there's nothing like seeing a handmade car, you know, kind of come together. And now with social media, you're able to actually watch it happen, you know, and it's not like watching it on TV where it's a whole car gets built in, you know, in an hour or something. We watch our friends build cars around the world that take a couple of years, and it's very interesting, and it's very exciting. So this isn't going to stop that. This is going to help some of that. It's going to do some of the thankless work, you know, that you don't necessarily love doing. And I've talked to a few metal shapers about this machine, and I think we all agree that we don't love making the same thing twice. We don't love making the rocker panel because it's just not rewarding, but we love making the body, right? We love that. Like, that's so great. So I think that's how this thing's going to work out. But imagine if you could make hubcaps, and you could make all these tins and all these other inner reinforcements that don't exist in the aftermarket. You know, I think that's going to be a major advantage to all of us. Now, I got a lot of comments on the posting on social media, you know, that I'm a cheater. I don't have any talent. I'm not creative. Like, none of that is real, right? Because I mean, I can do it, you know, I can do it the old way, and I still will. That's never going to go away. But there are ways, and there are times to use technology. And I mean, most of us are using CAD for the buck, right?
Yep.
There's a buck in CAD.
Yep.
So we already have the information. And
nobody would think about hand cutting a buck out.
Not anymore.
You would never think about that. Like, it would just be crazy, right?
Yeah. I mean, it happened, you know, but not anymore.
Sure.
When we make a chassis, you know, we're using CAD, and it's going to make the best chassis when you could use CAD and you could use CNC and make these things. So I don't see that it's taking away the handmade stuff. I think my example was shocking. You know, using the nose cone for a handmade car, that was shocking.
It was. You just grabbed it and you went right on the car. Right. And it just fit, and everything was beautiful, and you got the buck behind it, and you're like, voila, it was that easy.
Yeah. But I mean, I'm not fooling myself thinking the whole car is going to just snap together. You know, that's not going to happen. There's no way.
If we go back to when CNC machining came about, I'm 36, so I don't know, when did CNC machining, like we talked about the Bridgeport and like you whittling away on a block earlier, when did CNC machining become really, really prevalent in the car industry?
Well, for us, it was accessible to a shop like us. Yeah. In like the late 80s, right? 90s, like that. We were pretty early on for having it, and I think we got ours in around 90 or something, 91. Yeah. And it wasn't very common for a hot rod shop to have it back then. Now it's a bit more common.
Were people upset when CNC machining came about, or were they like, hey, look at all the profiles that we can create that we couldn't otherwise do on something like a Bridgeport because of curvature and depth and so on?
Yeah, I guess there was a bit of a divide on it. You know, it's like digital photography versus film. Like, you know, it goes on and on and on. You can say, well, and in that case, don't use Instagram. Like, you should take a Polaroid and go post it on the telephone pole. Like you know, like there's ways of improving things. How you choose to use it is the difference. Also, is every piece that comes off the figure machine going to be perfect? Well, I don't know, because I don't know who drew it. So who draws it? And does it take away the artist? No, because the art part already happened in the design. The art part happened when you designed the buck, or even, you know, before that, whatever the thing on paper was, the idea, whoever had the idea, that's when the artistry was there. And if you're going to bring in a American and chop the top, well, you're doing both. You're being an artist at the same time. So if you're going to cut the roof and you're going to stand back and you're going to look at it and make adjustments, you're being an artist, right? And then when it comes time to actually making the pieces, well, now you're using science, right? Because metal moves, it's predictable. So you're using science. So you're not taking away the artistry. in this at all because you've already designed your car and you designed the truck, and that's where the artistry is. How you get there, whether you use, I mean, I remember how many people were fighting about the Englishwheel versus the powerhammer. Like, there's that divide. I have both. I use both. Whatever is the right decision at that time. For that part. Yeah, I don't take a side. I go for the one that makes the most sense. So I mean, it's not going to take the artist away from it. I mean, it's not like it's AI, right? I see people sharing AI car designs. I mean, that's taking the human out of it, I think. Although I don't do AI art, so I don't know how much input comes from the human there. I'm not really, I don't know. But if you're going to make something on the figure machine, all the input came from a human's mind, right? Because you have to draw it and you have to tell it what to do. There's no fender button on the figure machine. You don't type it Tucker fender, and it's like, it just doesn't work that way.
Maybe one day, who knows, right?
Maybe one day. But right now, somebody intelligent still needs to make this plan, make it work, fail a couple of times, figure it out. That's always going to be there. It's still going to take a talented person, just like it takes a talented person to CNC out an engine block. Somebody smart had to sit there and do that, whether they did it on a CNC machine or they did it on a Bridgeport. That's still took an intelligent person to do it.
So let's talk procedure for a sec. So if somebody has designed the buck in CAD or designed the car and then reverse engineered the buck, I mean, once you have the buck in CAD, you skin it. Is that the procedure that the machine would come to understand?
Well, the machine will only take the input that you give it. So if you're going to make a section of body, right? So first of all, you have to break your car down into a size that fits the machine. Right. So no matter what the item is, it can't be bigger than what the machine can make. Now, we were over at Figur, and they were making the rear seat area for Hyundai. Okay. And I guess it was a prototype car. So imagine if you took the rear seats out of a car, what the floor looks like. It's very rounded, like there's very kind of a bucket, like a tub, and it has ribs in there that are whatever dimension that made up to the front half of that car, and it goes all the way up to the firewall by the trunk and around the wheel tubs. So this is a big piece. Yeah. And it took 2 hours, and they had to make a stack of them, and it took 2 hours to make one, and they were just piling up the stack of things. It's just doing them, and it's just knocking them out. It's crazy. And no one would be offended if they were made on a stamp, right? If they were just stamping them out, that's what we expect. So I don't see why you should be offended that it's being made on a CNC machine.
So what do you think it is? Do you think it's access? Like if using your idea here, we'll just go off on a tangent. Yeah. Do you think it's because it's accessible and it's taking away the artistry? In theory, it's taking away the artistry from the person who would otherwise be hand making that thing. No, they would not complain that a production car had this, seat pan stamped out. But it's accessible to the masses, which means you're taking away, like you're cutting somebody else's grass, type of thing. You know what I mean? Like there's a problem there. Do you think it's access? Do you think it's deflationary on the economic environment of the cost of this pan? Like, what do you think it is at its core?
I think as it starts to find its way into shops, people will become more comfortable with the idea.
Right.
It's threatening to some, but it really should not be. It really should not be threatening at all. People need to look at it as this is a way for me to get some help. I mean, every shop I talk to, same story. Oh, car takes too long, and I can't find any help, and I trained this one guy, and he didn't work out, and he screwed all this stuff up. Well, if you could get this stuff done without all that BS, right? You could get those rocker panels made, those door jambs made, get them made. I think that people will start to appreciate it.
Sure.
And they're not going to make a fender for an Auburn with it, so it's not going to mess with that, but it's going to make that very talented guy's life better and easier, because he can concentrate on that stuff. He can concentrate on the big, beautiful panels and not be bogged down with making the door jambs.
Yeah, I love
the
that.
inner fender panels, right?
I love it.
That stuff can get done. So I think that's when it'll start to become more comfortable. But make no mistake, it is not going to do what you can do with a power hammer and then all that stuff.
Mhm.
Whether it escalates and gets there, who knows? It could. I mean,
Mhm.
people have 3D printed complete cars, but
Yeah.
did that hurt anybody? No, because it's such a small number of people that are doing that. It's not having any impact on anyone else.
What about the limitations of the machine itself? So you'd
Well,
mentioned earlier, like
yeah.
you got reverse curve, you got compound curve, you get all this. Like, what can it not do?
Well, it can only stretch metal so far because it's not shrinking.
Mhm.
So that's the thing that you have to kind of understand. If it's a piece that can be stamped, then it can probably be done with a figure machine,
Mhm.
because it'll eventually get too thin, and then you got a problem. So you have to strategically lay out your parts, which parts are good choice for the system, which parts are not. And that comes with experience, you know,
Yeah.
and I don't have enough experience yet. I picked that one piece because I knew that it would be a pretty radical thing for it to do. Let's see how it does there, and it
Yeah.
did well. So that was good. So what can it not do? I really don't know yet.
Mm.
I think that there's going to be some going back and forth because now we're talking about sheet metal. Sheet metal bounces back. You know, it's not like CNC cutting into a block of metal that whatever you cut goes away and it does exactly that. This does react, right? It reacts like sheet metal, and we're all
Mhm.
familiar with, you know, how that works. So yeah, it'll push, it'll do everything that you told it to do in the program, and then if you take that piece off and try it on the buck or rescan it, and then maybe digitally lay that scanning over your original one, you can see if it's accurate or not. And
Yeah.
if it's not, then you could make adjustments. But the good news is, all right, so it took me, 3 tries to make it part, but they were only 30 minutes each.
Yeah.
So no big deal,
Yeah.
If you had a hand make, 3 parts, you'd have a problem.
That's right.
So the the idea of having that kind of trial and error thing in the beginning, I think, is going to be important, and then hopefully with more experience and more time, more understanding of what to expect,
Mhm.
you can probably make those adjustments even beforehand.
Yeah.
Yeah.
I want to talk to you about cost, but before we go there, is this machine or is this computer software able to take something and form it or shape it out of arrangement? And then you can pop it back into arrangement depending on how the shape actually looks when you get it out of the machine.
I don't think so.
It's not quite that sophisticated yet.
Explain to me again what.
Yeah, sure. So like if you take a motorcycle fender, for
Yeah.
example, you can
Mhm.
curl it up, you can put it through the wheel, and then you can straighten it back out and it
Yeah.
becomes your fender,
Mhm.
right? And depending on how you do that, it gives you more access for your anvils and so on. Is this
I got you.
3D tech, is it able to say, okay, if we form it in this way with the way that it actually does the maneuvering on the panel,
Yeah.
when we take it and pop it back into the shape that we actually want, right? Can it think that far ahead, or is it not there?
Well, it's a little bit different thinking on this. So I have a fender that's pretty similar to what you're describing.
Yep.
It's a fender for this karaoke, which looks like a motorcycle fender.
Mhm.
And so what we did was we split the fender into pieces and digitally laid it out that way. So when the parts get cut out, now they fit. So
Ah,
there's some wasted area in between,
yep.
but it's all predictable. And there's what we call a poke line,
Mhm.
or a ghost line. So we know right where to cut it. And
Gotcha.
those things are laid out and already figured. So when you cut the pieces out, they go together.
So did you do a physical master and then you copied the master?
No, it was all digital.
Oh, well,
Yeah, all digital. Yep.
very cool. Cost. Let's talk cost. What does this cost? So the nose cone, using your nose cone as an example, what would that have cost somebody to like hand shape it and make it so versus on this tech?
That we don't know yet. We know that it took 35 minutes, but we don't know what 35 minutes cost yet, just
Mm,
because we don't have enough experience yet.
okay.
So what does 35 minutes cost on this thing? I don't know. Um, like 3D printing is a little bit different charging than manual labor, right? So there's going to be, some of those formulas that still need to be kind of understood. Again, as time goes by, we'll know more about it. We know it's fast. We just don't know how much a minute cost.
Sure.
35 minutes, but how much does a minute cost? We don't know yet.
Mm-hmm.
But we know that it's fast. Yeah. So that we like. So a little too soon to know how much parts will cost, but I would say, like, if you're going to make, like I mentioned earlier, a trunk section for a car, kind of an obscure car, one that's not in need of building a tooling or stamp or anything, but you know that you're going to make more than one.
Yeah.
Having that file, there's value in that. And then being able to make a piece that might cost a couple of $100. I mean, I think that's great,
Mm-hmm.
Yeah, because, right now those things just don't exist. Like, even on a Porsche 356, we buy like replacement rocker panels or door jamb sections and stuff, and they never really fit great. They're all rounded over, and it's just basically something to work with. So sometimes we just make our own, or we work with something that, is close, but still needs a ton of handwork. So that's where this thing is gonna really be efficient, and those parts should be very inexpensive.
And what do you think could be next for this tech? Like, if we go 5 years in the future,
Yeah.
Knowing what you know about it now in its infancy, like, where do you think this could go, such that, like, people are buying body kits and they're assembling them? Do you think that this is more of like a rapid prototyping tool for industry? Like, where do you think it could go in all of its uses?
I think it's going to follow the same path as 3D printing,
Okay.
because it's available in industry. It's been around for a long time, right? That technology's been around. It just hasn't trickled down to someone like me, until now, because it's been just very expensive, and it's never really been perfected. So I think that's kind of a big piece of it too. But I think it's going to follow the same path as printing, where people will start to think like, oh, how can I use that? And with that comes new ideas, rebodying things. I mean, wide bodies are a big piece of the like European market, right? A lot of those guys are doing wide bodies and body kits, and they're screwing on plastic or however they're doing it. But now you can actually make your own wide body.
Yeah.
And people will, I think they will.
It's pretty neat.
Yeah, it is.
It's very neat.
It is.
Yeah, if you got a Volkswagen Golf or something and you want wider front fenders, well, you don't just buy the flare now. You buy the whole front quarter, and you take the old quarter off and you put the new one on and paint it, right?
Yeah. Yeah. And imagine, like, trim. A customer of mine has got a 47 Cadillac, and he's got actually a lot of them. Like, he loves those cars. And apparently the body side molding, which is like this long tapered piece, I guess they rust away. So he's always on the lookout for them, and he buys them when he can, but they're hard to come by. And then he's asked about, or he's examined reproducing them, and it's never really made sense because there's not enough customers for him to pay for his tooling. So he's just been kind of doing whatever he's got to do. But this could certainly do it and make it reasonable, and he can make that trim, and he could make one now and one next year if he needs, and it's fine. So
when does this become mainstream? So that somebody says, hey, Rob, I want a piece. I'm going to give you a call this afternoon, and you can have it back to me in 2 weeks. Like, when does it become no longer in the prototype phase in its infancy? When is it mainstream? When can we use it?
I'm thinking that you'll probably start to see parts being put out to other shops 6 months. I think 6 months to a year is when I think this stuff will really start to be usable and seen and thought about and figured into projects.
Sure.
Yeah. And that time goes fast. It does.
Are you going to have one of these machines in your shop? Is that the plan?
That's the plan. Yeah.
Yeah.
So the plan is to have one in my shop, and we'll use it for the cars that we build. And we'd also like to make the service available, which I think is really kind of the cool thing here, is that, like, we use send, cut, send for a lot of things, right? We used to machine all our own brackets, and sometimes we do, but now, I mean, I could just send them a file, and while they're laser cutting the thing on their latest and greatest equipment, I go on to something else, and now I'm doing something else in the shop. And then a couple of days later, I open a box, and there's a piece that we designed, and it works. Yeah. And it's been it's freed up a lot of time of me, standing in front of a bandsaw, and instead of doing that, I could be doing something more important with my time.
There's nothing more boring than making brackets.
Yeah, right.
Terrible.
Yeah,
terrible use of time. Oh my
and
God.
I don't care what you say. There's not enough money to pay somebody to stand there and make you a bracket. It's just
Right.
it just doesn't add up.
Yeah.
But I mean, do I do that with every piece I make? No, because sometimes I need to keep moving. So I'll run over and I'll cut something on a bandsaw, and whatever makes sense, makes sense. But if I could design a whole thing, like right now we're doing suicide doors on a Pullman 600 limousine. So it's a 6-door limousine. They're rare cars. This one belonged, I'm told, belonged to the dictator of Romania. And so my customer bought this car, and he wants to make it more of a luxury type limousine. And the middle door on the 6-door is very tiny. Like you can't even really use it. So the idea here was cut out the post and make the rear door suicide. Now the car is wide open.
Neat.
So, the old way, I would have made all cardboard templates and, cut out all the pieces and made a suicide door, and it would take a long time. So here I still designed it. I still engineered it, but we did it on CAD. We had the parts laser cut, and when they came in, I installed them. It was great. It was like, painless, and it worked. Everything worked the way we designed it to work.
Yeah.
So I'm imagining that kind of convenience with Figur. If that can help people get somewhere, and they can help get that trunk floor in that car, or get those engine tins on something that are missing, some old restoration that half the parts are no longer in existence. This will help get that stuff done. Trim, brightwork and trim.
Yeah. Yeah. Do they know what the machine's going to cost yet? Has that been released?
The machine's about $500,000.
So it's a significant investment.
It is. Yeah.
Yeah.
It's an expensive piece of equipment to have. But I mean, think about how much money we invest in all the metal shaping equipment that we own already. I mean, it gets expensive. It really does. And then you have to, support that with time. And none of it is cheap. It's not. So
and one person, at least one person, to do the programming and the scanning and the CAD and all that stuff, right? Because as you say, it doesn't just operate itself. It's
correct. Yeah, and then you have to still put the pieces together. So you still need a talented metal finisher or shaper to put all these things together and make a car out of it, or whatever you're trying to make.
What's next for you? What's going on? What's going on in the shop? What's next for you?
In the shop, well, we're working on a few things. I mentioned that the Tucker 29, which was Preston Tucker's personal car. So we're finishing a restoration on that. That's about the only car I really restore is a Tucker, or I'll do some vintage race cars just because I love them. But we're not really so much of a restoration shop. We're really a custom shop. So we do a lot of hot rods and customs. I mentioned the Pullman 600 6-door limousine. So that's a pretty crazy job that we're working on now. At first I wasn't really interested in that one. I passed on it, and then I started to learn more about how interesting that car actually is. And then now I'm totally into the car. I think
sure.
Yeah. I just didn't know enough. We have a Jaguar E-Type that we've completely redesigned. It's a Jeff Allison design, and so we're making the car for Marcy. That's the car's owner. It's been on hold for about 2 years now, and she said I can get back on it, but a few other cars now are kind of got in front of it in the meantime. A 63 Corvette that we rebodied. It's completely redesigned, all different proportions. We moved the roof down and back, lengthened the nose. So working on that one right now. An old custom 40 Ford convertible that was built in the early 50s, working on that one. And that's in the shop. Converting a Willys 4-door sedan into a sedan delivery. That's here now. And there's
that's a lot of cars, man.
Yeah, a 57 Cadillac. Beautiful 57 Cadillac that we designed a bunch of trim on it. If you look on my Instagram, pretty recently I redesigned some trim on the fender, and made that by hand. Well, the piece that I made by hand would probably be a pretty good candidate for a Figur part. You know, and you can make both sides the same, do all your design work. You can take a scanning of the fender, do your design work, make the piece on figure, and you probably make it out of multiple pieces, maybe 2, and then finish them and metal finish and chrome plate them.
Very cool.
But yeah, that's what we do here, just custom cars. And then the Carioca, which is the Tucker concept car that Preston Tucker was working on at the time of his death in 1955. After he closed the car company, he moved to Brazil and started to dream up a new car, and it would be a sports car, kind of like a Porsche Speedster, right? So it's a 4-cylinder, air-cooled, opposed engine, rear engine, lightweight, nimble, very low, very small, and it had the 3 headlights like a Tucker sedan.
Yeah.
Kind of reminiscent of a Tucker sedan on the front bumper and air intake. It had fenders that steered with the wheels.
No way.
And the hubcap remained stationary because the hubcap was part of the fender.
Wow.
Cool. Yeah, so the tire would spin.
Yeah.
Hubcap remained stationary attached to the fender. Kind of
wow.
idea. Now he didn't do any mechanical drawings on this car. It was completely just renderings only, just artist renderings. There was no engineering done. So we took what he did leave behind, the artist renderings, and then we did the engineering, built a CAD model of the completed car, fitted a Franklin airplane engine, because Preston Tucker owned Franklin, right? That was his company. So we found the correct engine that we thought he'd use. And we even built torch elastic suspension. Now, Preston Tucker had this idea, even in the sedans, he didn't use coil springs or leaf springs. He used torch elastic. So imagine like this small little can with bonded rubber in it.
Yep.
And that was the suspension. That was the spring that bonded rubber. Yeah. So we made that for the little sports car. So the Carioca is what we think it would have been like had he got to make the car in 1955. So
wow.
Yeah. So very right now the chassis is completed on it. The engine is in. Suspension is all done. We're working on the induction right now, and then I'm going to start making the body. And so, as you saw, I made the nose cone with figure. I don't know how much of the body I'll do with figure. Where it makes sense, I'll use that.
Sure.
And where it doesn't, I'll make it the old way.
I think
door jams and inner door boxes, I'm very, very excited about.
That's amazing, man. I think if there's anything that I'm going to take from this episode today is just knowing that, like, you as an entrepreneur and also an artist, how you've combined the two, but you're also saying, okay, what's next? Is it the figure tech? Is it merging figure tech into the modern day industry where you still need old world craftsmanship, but this modern technology is making us more efficient, and it's making us, be able to execute some of the menial tasks and the stuff that isn't quite as fun to build. But, you're still able to say, hey, we're going to bring this in the shop and we're still going to make beautiful stuff. We're just going to do it a little differently now. And I think that's super cool. So from me to you, thank you so much for being here and talking about this tech and what you're working on. Where can people find out more about you?
Instagram, Rob_Ida on my Instagram page. I keep that updated as much as I can. And that's about it. I don't have a YouTube. I might have a YouTube channel that I haven't looked at in 15 years. So Instagram is best.
Fantastic. Well, thanks for being here. And thanks for checking out the Sheet Metal Shaping podcast. Don't forget to like, share, follow, subscribe, and tell a friend if you enjoyed this episode. And we will see you on the next episode.